Come back. Now, we want to use the formula for area of a surface. Which formula? This formula. Area 2 pi RL. A surface area of a figure which looks like this. Side length L, R1 and R2 being the two base radii. So what is R? R is the average of R1 and R2. Then the required surface area is 2 pi RL. We are going to use that formula to find the surface area of the surface obtained by rotating the curve y equals fx between values x equals a and x equals b about the x-axis. Notice f is positive valued and has a continuous derivative. Okay, we have continuous derivative. So when you rotate it, you obtain a certain surface. You want to find its area, surface area. Now notice, you take this particular surface and consider strips on the surface. When you consider such strips, notice the point here, for instance, is xi, yi. The point here is xi plus 1, yi plus 1. Where, what are the y coordinates given by? They are given by the value of f on x. Now, for each strip, let's consider the average radius. So radius would be, one radius will be the y coordinate here, that is yi plus 1. The other radius will be the y coordinate out here, so that is yi. So the average of the two is r. R is f of xi plus f of xi plus 1 over 2. The slanted length, this length, okay, is given by distance between the points xi, yi and xi plus 1, yi plus 1. That is, L is square root of, using distance formula, xi minus xi plus 1 squared plus yi minus yi plus 1 squared. Xi minus xi plus 1 is what we'll call delta x. Okay, assuming all these strips are equally distant, we'll call xi minus xi plus 1 squared as delta x squared. Yi is fxi, yi plus 1 is fxi plus 1. So that difference is fxi minus fxi plus 1 square is squared. Now, let's use the mean value theorem. By the mean value theorem, there is a sample xi star between xi and xi plus 1 such that the derivative of f at xi star is fxi minus fxi plus 1 over xi minus xi plus 1. So mean value theorem is applicable when your function f is differentiable. All right. So when you take the derivative and f prime at xi star is this ratio. What does that mean? fxi minus fxi plus 1 equals xi minus xi plus 1 times f prime xi star. So squaring it would be squaring this and squaring this. But this is what we call delta x. So xi minus xi plus 1 squared is delta x squared. And you have f prime xi star squared. This, recall, we obtained by using mean value theorem. Therefore, the side length of each strip is square root xi minus xi plus 1 square plus yi minus yi plus 1 squared. This being delta x squared, this being fxi minus fxi plus 1 squared. So by mean value theorem, we just saw this square is delta x squared plus the derivative at some point squared. Get this common term out, common factor out through the square root. You get delta x outside, and inside the square root you have 1 plus derivative of f at some point xi star squared. Further note, what was the radius? yi plus 1 over 2, which is fxi plus fxi plus 1 over 2. Now, if the strip is thin enough, then fxi is approximately fxi star. Likewise, fxi plus 1 is approximately fxi star. Therefore, the radius r, which is average of these two, is approximately fxi star plus fx star over 2. In other words, it's simply approximately fxi star. So the surface area of the strip is 2 pi rl, 2 pi fxi star, L being the side length we just saw was delta x square root 1 plus f prime xi star squared. So finally we are to the surface of revolution. Now what do? You take such strips and let number of strips go to infinity. Take the summation of all the areas of all those strips. This translates to limit n approaching infinity, summation I going from 1 to n, 2 pi fxi star delta x square root 1 plus f prime xi star squared. I'll write the delta x on the right hand side so you can visualize what happens. This limit of such a summation, if it exists, this is what we call integral. So surface area is 2 pi integral a to b fx square root 1 plus f prime x squared dx. Alright. So 1 plus f prime x, you may also write it as 1 plus dy dx squared. Alright. Fx is y. Since the arc length is this quantity, right, we may also write this as ds. Okay. So surface area is 2 pi a to b fx square root 1 plus f prime x squared dx, which is same as 2 pi integral a to b y square root 1 plus dy dx squared dx, which can also be written as 2 pi a to b y ds. In a similar fashion, you may consider the surface of revolution obtained by rotating the function gy about the y-axis. So here x is a function of y, gy. So gy is x, g prime y is dx dy. Okay, the problem is similar. It's just change of rotation. You may say c to d x ds. Okay.